Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will learn about over-consolidated soil, which is also referred to as pre-consolidated soil. Second is normally consolidated soil. Third one is under-consolidated soil. And finally, we will learn about over-consolidation ratio, which is referred to as OCR. First one is over-consolidated soil. Let us consider a layer of clay over which there is glacier. Let this dotted line represent the midpoint of the clay layer. Due to presence of glacier, the soil is being pre-consolidated. Over a period of time, the glacier will melt and the effective stress decreases, and we can see that this line represents new midpoint of the clay layer after soil rebound. X was the initial level of the midpoint of the clay layer when there was a huge glacier, and Y represents the new midpoint of the clay layer after melting of the clay. That means in past the soil is subjected to effective stress which is more than the present applied effective stress. The present applied effective stress is reduced because of removal of the load, that is due to melting of the glacier. And we say that these soils have been subjected in the past to a pressure more than the present overburden pressure. Here the overburden pressure is less due to melting of the glaciers. Erosion of soil or removal of overburden form the over-consolidated soil. Now we will find out how to determine pre-consolidation pressure at point A. Let this dotted line represent highest ground surface in the past, that is when there was overburden. Let H be the depletion of the ground due to removal of the overburden. So the second line represents current ground surface. If you want to find pre-consolidation stress at point A, we need to multiply unit weight of the soil, that is gamma, to the total depth, that is H plus Z. So sigma P dash, that is pre-consolidation stress, will be equal to gamma into H plus Z. And pre-consolidation stress is the maximum effective stress the soil has experienced in the past, and it is also referred to as the temporary overburden pressure to which a soil has been subjected to and under which it got consolidated, and it is represented by term sigma P dash. And if you want to know what is the current effective stress, then sigma C dash will be equal to gamma into Z. Over-consolidation causes an increase in strength, reduction in permeability, and a reduction in settlement. There are several causes of over-consolidation. They are excavation or erosion, glaciers, desiccation of soils, that is shrinkage of soil, and lowering of groundwater table. If the current effective stress, that is sigma C dash, after melting of the glacier is less than the pre-consolidation stress, that is sigma P dash, when there was a glacier over the layer of clay, then the soil is said to be over-consolidated, and these soils are less compressible and more stable, hence are preferred for construction of any structure. Next, we will find out what is normally consolidated soil. Here we will consider a soil element which is made up of soil particles, and there will be voids in which there will be presence of air and water. Let there be layers of soils over this soil element which are formed due to deposition. So, due to deposition of these layers, effective stress on the soil element increases, whereas voids ratio decreases due to removal of air and water from the voids. And when we plot a graph of voids ratio versus effective stress, we get a straight line. And this line is referred to as normally consolidated line, which shows that voids ratio decreases with the increase in effective stress. If the soil has never been subjected to an effective pressure greater than the existing overburden pressure and has been completely consolidated by the existing overburden pressure, then it is called as normally consolidated soil. And these type of soils are loaded first time in the history to the present applied effective stress. These soils are more compressible and hence undergo high settlement when are loaded. Third one is under-consolidated soil. If a clay is not fully consolidated under the existing overburden pressure, that is due to filling of the soil, then it is called under-consolidated soil. Next we will find out what is over-consolidation ratio. It is defined as the highest stress experienced by soil divided by the current stress. So OCR is equal to maximum overburden effective stress divided by current overburden effective stress. Maximum overburden effective stress is denoted by sigma P dash and current overburden effective stress is denoted by sigma C dash. If OCR is greater than 1, then the soil is referred to as over-consolidated soil. That means sigma P dash, that is overburden effective stress, is greater than the current effective stress. Hence, OCR is greater than 1. If OCR is equal to 1, then the soil is referred to as normally consolidated soil. That means current effective stress, that is sigma C dash, is equal to the pre-consolidation stress sigma P dash. So, sigma P dash is equal to sigma C dash, hence OCR is equal to 1. And such type of soils are referred to as normally consolidated soils. And if OCR is less than 1, then the soil is referred to as under-consolidated soil. That means sigma P dash is less than sigma C dash. Thank you.